Okay, so on linear function and labeling, we're gonna start looking at linear lines. A linear line makes a straight line because it grows at the same rate. Okay, that's what a linear is. And we will talk a little bit more about linear, but I want you to go ahead and write that down. So linear lines have the same rate of change. So they will change so consistently. So they'll go up the same amount over and over. And so it will be the same amount of increase or decrease every single time, but it's not going to fluctuate. It won't go up and down. It will be the same change over and over. Now, when we talk about rate, and we're looking at equations, rate is the measure of change in the unit. Now, there's a quick way that you can find rate. Rate is always by the word each, every, per. So if you find those words in a word problem, you will find the word rate. Y-intercept is where it touches the x-axis. It is usually a starting point or the initial value. It's typically where it begins. And an equation is made up of the y-intercept and the rate. Now, the x variable is going to represent the unit that comes after the word per in the rate. Okay? So when you find that word per, that's also going to help you identify the x variable. And remember, we said that x variable is my independent. So remember, we've been talking about independent and dependent variables. The x variable is your independent, and it is always after the each, every, per. Okay, so it will be after. And then you have the f of x, which f of x is another name for y, and that is your dependent. Now, your dependent variable, it will usually represent some type of total. And you want to use your clues from the numbers, like from what the numbers are, to see what it represents. Okay, so use the clues from the other numbers, from the numbers not by the x. Okay, so we'll look at a couple. On number one, Mr. Lackey rent a car. The rental company charges a fee of $35 and charges 35 cents per mile the car is driven. The function f of x equals 35 plus 0.35x describes the total cost of Mr. Lackey's rental car. Identify the following. So, very first thing, you have an equation. I'm going to write my equation a little bit bigger because, remember I told you, anytime you see an equation, it's very important that you write it down because you are probably going to use that equation. Okay? Now, there's my equation. Now, if I go back and look at the key words, per. Okay, see that per, 35 cents per mile? These two things go together, 0.35 m. See this right here? These go together. So my rate is 0.35. It's what's in front of the x. It's what's in front of that word per. That is my rate, 0.35. Whatever is in front of the x is called your rate. Okay, it's called your rate. Now, it goes with the word mile. And remember, the x, there's my x variable, 0.35 goes with what? Per mile. So the x variable represents the number of miles driven. Okay, the number of miles that it's been driven. Now, what other information am I given? I'm given that the rental company charges a fee of 35. So you see, this 35 doesn't have a variable, okay? This 35, there's no variable. So that tells me that is my y-intercept. If there's no variable, it is my y-intercept. That is my starting value. That means just to go in and get a rental car, I'm going to have to kind of make a deposit of $35. So my y-intercept is $35. Okay? Now, remember the f of x, use your clues. What's everything else about? The f of x, this, it's not the miles, I've already used the miles, but what is in front? See see that dollar sign and that dollar sign? So I know that my f of x has to be about money. It's about money. And the words up here for about the money, it charges a fee, or the total cost. So 35 is my fee, but the f of x represents the total amount, the total fee, or the total cost I'm gonna have to pay. It's about money, all right? That is a linear function. I start at 35, but every single mile I'm gonna go up 35 cents, and it will go up the same amount every single time. Number 2. Mr. Lincoln packs jars of popcorn kernels into a packing container. The container has a mass of 1 4500 kilograms. The mass of each jar of popcorn kernels is 8500 kilograms. The function f of x equals 8500 x plus 1 4500 describes the total mass. Identify the following. Very first thing, I have an equation, so I'm going to write that down again so that you can see it and we can add a little bit to it. Okay, first thing, that word each, okay? The each. What is in front, or what goes with the word each? Look at the sentence. So the sentence is from here, goes to here. There's my sentence. So what's in that word each? 0.85. Okay, so look at the 0.85 and notice it goes together with the x, right? What is the x? 0.85 goes with each what? Jar. So 0.85 is next to my x, so that is my rate. So my rate is 0.85 for each what? Jar. So that means my x represents jars. Okay, that's the number of jars. So I'm packing a box and I'm putting jars of popcorn kernels in them. So the x represents the number of jars. Each one is going to hold this much popcorn. Well, what was my starting amount? Okay, what was my starting amount? The container has a mass of 1.5. See this 1.45? This one has no variable. Okay, if it doesn't have a variable, that is my y-intercept. It is my starting point. So that means before there's any jars, before there's any popcorn kernels in there, my box, my empty box, weighs 1 4500 kilograms. Okay, that's the box that I'm packing the jars in. So the one that doesn't have a variable, that's my y-intercept. That's my starting point. So I'm going to start at 1 4500. Now, what is it about? Look what everything else is about. Now, use your context clues. I have numbers 0.85 and 1.45. Look up there what it says. 1.45 kilograms. 0.85 kilograms. Look what's in both of those. Kilograms, kilograms. So what is my f of x variable? It is kilograms. That is the total, it is the total number of kilograms that my box will weigh. All right? Over here, you know, we had money on both of those. So the dependent, remember this is your dependent. The dependent, you can take the context clues from the numbers to see what they're about. The independent is the one that's always behind. It's the one that's always behind the word per. Okay, but the dependent can come from the context clues of the other two numbers. All right, so Tony has 12 visits per month. Write an equation that could represent the amount of visits that Tony will have in X months after his surgery. Okay, there were some things that were left out in that problem. So I have to write the equation first. Tony has 12 visits per month. Again, there's my word per. That's my times. So 12 times what? M equals, now what is it about? It equals the number of what? Visits. Okay? So, whatever is in front, here's my M. Whatever goes in front, 12, that is my rate. Another word for rate is slope. So, rate is slope. So, it's 12. Okay? And the M, goes with that 12, so this is my X, that is my independent. So the independent is months. The dependent, that is your function, and it's about, that's my Y, that is my dependent. What's it about? It's about the visits, the number of visits, okay? The one that's behind it is always the independent, the one that's in front is your dependent. Identify the y-intercept. Well, there's nothing there. There's not anything that's plus or minus. If you have 4 plus 0, isn't that the same thing as 4? Well, 12m plus 0 is the same thing as 12m. So this plus 0, that is my y-intercept. So if you don't see anything there, it's a 0. Now, linear. We're going to graph these. Remember, linear is going to make a straight line. It's the same rate of change. So it's the same rate. It will not go, it won't change, it won't be steeper and then flatter. It will be the exact same. And it will go either all go up or all go down. So -3, -2, I go to the left 3 and down 2. Left 3, down 2. Okay? Next one is 0, 3. So I stay put and I go up 3. So stay put at 0, go up 3. And then the last point is 2, 2. I go to the right 2 and up 2. So right 2, up 2. Now notice, look at my line. I went up and then I went back down. Okay, I can't do that because that's not the same rate. I would be going up the whole time. So is it linear? No. -3, I go to the left and then I go up, +3. So -3, 3. -2, up 2. So -2, up 2. And then I stay and I stay, 0, 0. Okay? Now if I draw this line, notice I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. It's the same rate over and over. So yes, that is linear. On the next one, this one have a graph, but this is a curve, so that is not linear. Is this linear? Yes. You go up and over the same amount over and over. And I can't really see the lines very well. I don't know if they print off very yours, but if you notice each box, it's exactly the same. I go up 2 over 1, up 2 over 1, up 2 over 1, and I land on the line. This one I didn't draw very well. So up 2 over 1, if you notice every single time you go up 2 spaces over 1. And so is it linear? Yes, it is linear because it's the same rate of change.